Swapping and grouping. Example 6. Madhu is flying drone from a terrace. The drone goes 6 meter up and then 4 meter down. Write the expression to show how high the final position of the drone is from the terrace. So first the drone is up for 6 meter and down by 4 meter. So the terms are minus 4 and plus 6. So the expression is 6 minus 4 equal to 2. We can write the expression in terms 6 plus minus 4, that is equal to 2. Interchanging the terms we get minus 4 plus 6, that is also 2. So we can conclude that swapping the terms does not change the sum. So we can write term 1 plus term 2, that is equal to term 2 plus term 1. While adding positive numbers, grouping them in any of the above two ways gives the same sum. Will this also hold when there are terms having negative numbers as well? Yes. Let's do some problem. Take some terms minus 7, 10, minus 11. So we can write these three terms in any order. First one is minus 7 plus 10 plus minus 11. We got minus 7 plus 10 is 3. 3 minus 11, that is equal to minus 8. Next, minus 7 plus minus 11, that is equal to minus 18, plus 10 equal to minus 8. 10 plus minus 7 plus minus 7 minus 11, that is also equal to minus 8. 10 plus minus 11 plus minus 7 also minus 8. So swapping the terms does not change the value. We can say that if the negative terms are adding, then it also gives the same value when the terms are interchanged. Thus grouping the terms of an expression is in either of the following ways gives the same value. Commutative property. Commutative property shows that term 1 plus term 2 is equal to term 2 plus term 1. Take x and y as the numbers, then we'll also say that x plus y is equal to y plus z. Commutative property of addition. It states that term 1 plus in bracket term 2 plus term 3, the sum will be equal if we add first term 1 plus term 2, then add term 3. In terms of x and xyz, we can say that x plus y plus z equal to x plus y plus z. Let's take another example 8. Children in a class are playing fire in the mountain, run, run, run. Whenever the teacher calls out a number, students are supposed to arrange themselves in groups of that number. Whoever is not part of the announced group size is out. Ruby wanted to rest and sat on one side. The other 33 students were playing the game in the class. The teacher called out 5. Once children settled, Ruby wrote 6 into 5 plus 3, understood as 3 more than 6 into 5. First, the teacher called the number 5, then the children are grouped in fives. The remaining children are 3, were standing other side. So the expression of this equation is 6 into 5, that is 6 group of 5s plus 3. The total number of students is 30 plus 3, that is equal to 33. If the teacher had called out 4, Ruby would write 4 times 9, that is equal to 36, which is greater than 33. So, 9 groups are not possible. So 4 times 8 we have 32, that is less than 33. So we can group the fours in 8 groups and remaining children is 1. Next, the teacher called the number 7. So 7 into 5 is equal to 35, which is greater than 33. So um, 5 groups are not possible. 7 into 4 is equal to 28, which is less than 33. So 33 minus 28 is equal to 5. So the children grouped in 7. The groups are 4 and the remaining children is 5. Another example 9. Raghu bought 100 kg of rice from the wholesale market and packed them into 2 kg packets. He already had 4 2 kg packets. Write the expression for the number of 2 kg packets of rice he has now and identify the terms. So Raghu has 100 kg. He divide the 100 kg into 2 kgs. So the number of bags of 2 kgs are 100 by 2. Raghu already have 4 2 kg bags. So the total number of 2 kg bags he has is 4, which is already he have, and plus 100 by 2. The terms are 4 and 100 by 2. So the value of the expression 4 plus 100 by 2 is 4 plus 50, that is equal to 54. Another question, example 10. Kannan has to pay rupees 432 to a shopkeeper using coins of 1, rupees 5 and notes of rupees 10, rupees 20, rupees 50 and rupees 100. How can he do it? Let's split the number 432 to 400 plus 30 plus 2. In 2 we can give 1 rupee coins, 2 1 rupee coins. 30 can be given in tens and fives. So uh, 1 rupees and 4 5 rupees notes. 400 can split, that is we can give 100 rupees, 50 rupees and 20 rupees, 100 rupees 2 and 50 rupees 2, then we get 100, 20 rupees 5, we get 100. It will make 400. So the expression for this is 2 into 100 plus 2 into 50 plus 5 into 20 plus 10 plus 4 into 5 plus 2 into 1. Or we can give in another way, 1 rupee 2 coins and 10 rupees 3 and 400 can be given in 400 rupees. So the expression will be 4 into 100 plus 3 into 10 plus 2 into 1. Or we can give another way, 2 into 1 rupees, 4 into 5 rupees and 1 into 10 rupees. It will make 30 and 8 into 50 rupees, that is 400. So the expression will be 8 into 50 plus 10 plus 4 into 5 plus 2 into 1. So there are many expressions. The answer will be same. Lastly, we can discuss the problem 11. Here are two pictures which of these two arrangements matches with the expression 5 into 2 plus 3. So in the first picture, there are 5 2 blocks and 1 3 block. The 5 into 2 plus 3 is the expression. In the second picture, there are in one block is 5 yellow and 3 blue. So 5 plus 3, which are in number 2. So we can write 5 plus 3 into 2. So the answer is first picture.